Okay, so today we're going to be looking at hasattr and super. Now I'm just gonna get rid of a few things. I've done this a few times just before I recorded, so we're gonna just define the class because we're already pretty familiar at this point, right, with this class. Okay. Now to make an object from this class, all we do is cake. We give it a name, just a cake. Let's say fudge cake. Fudge cake. And the fudge cake's going to be $5, and the flour used is going to be regular. Let's say bread flour. Okay, so yeah, we can see that this is an object of the cake class. Now, if I want to check to see if there's something inside of the cake class, let's just see. Let's just say I want to check to see if I've stored the flour used, right? Which I have. I know that I have. I can see it. I can use something called has attributes. I say print has attra, and then I type in the name of the object, which is cake, and then the value that I want to check. So it'll be flour used. And this is going to print out true. If I type in price, well, price is defined here, so it'll be true. If I do self, let's see what happens. I think this should print out true. Oh, false. Okay, well, that's fine. Self maybe is invisible to the object, but that's fine. Okay, so we can see, oh, and actually there is, this should be name. There we go. Self and name is equal to name. There we go. False, but if I do name, okay, there we go. Okay, so I made a mistake with how I made the cake class. Okay, good. So this makes much more sense now. Now let's define a second class, which is going to be a class of, let's do a class of pastry. We'll do pastry right here. And then inside of pastry, instead of flour used, I want to track nuts used, right? Because it's much more common to have nuts inside of a pastry. Well, for some pastries, that is true. So we're going to define the object or create the object here. Pastry is equal to, this should be a lowercase, pastry is equal to pastry. We're going to say it's a vanilla cream, and I've spelt this intentionally wrong because this is how it's spelt in French, which is where the pastry originates from. And we'll do 5, well, let's just do 6, make it different. And we'll say nuts used, yes, almonds. Almonds were used. Wonderful. So now if I run, there should be no errors, and it should still say true. Okay, so now I want to check the pastry object, which is right here, pastry. Well, pastry has a name, so it's going to be true. Does pastry have flour used? It does not. Only cake has flour used. So what happened by typing flour used? It's going to say false. But if I use nuts used, it's going to be true. So we can now check to see if a class has a certain value defined, right? Which is really useful when your application gets really big. Instead of having to look through your application, you can just use a conditional statement to double check that something is true. Okay, sorry that I just sneezed, but I switched off my mic. Okay, so the next thing we're going to be doing now is using a iterative approach, which means we're going to type in sweets. Inside of this, we're going to define an array, cake and pastry. These array items are equal to these objects right here on line 15, line 16. So if I now say for S in sweets, what this is doing is it's looking through everything in this array, the sweets array, and it's going to call each item S. So first it's going to call cake S and then pastry S. So then we can search for things pretty easily, right? Iteratively, which means one by one. So we can say for S, if S, let's say, yeah, if S, if has attribute S, and let's just check for bread flour. Oh no, we'll check for, sorry, flour used. Flour used. We're going to say print, let's say print s.name uses s.flour used. Let's see what happens when we press run. So yeah, fudge cake uses, you can get rid of that, fudge cake uses bread flour, very good. However, we also want to check to see if the pastries, or we want to do the same thing with pastries, right? So we want to print out something special when pastries have nuts used, which they do. So we'll type in elif, has attribute. We're going to use S because remember S can be used to represent cake and pastry, our objects, because they're inside of an array. I will say nuts used, like so. And we're actually going to copy and paste this across just so it's easier, like so, making sure to change it right here, which is nuts used. And there we go. Okay, good. So fudge cake uses bread flour and vanilla cream uses almonds. So you can see how we've defined our classes. We've created objects from our classes. We're able to put them inside of arrays and then check to see if they have certain values using the has attribute method. Really good. Okay, so next we're going to be moving on to super. Now, super is very easy, okay? And we're going to be using wizards and characters and that kind of stuff now, just to go back to our regular theme. So if we define something as class character, inside of this we'll do define init self name HP and self dot name is equal to name, self dot HP is equal to HP. There we go. We're also going to define a class of, well, okay, this is our base class. This is our parent class. Now we want to make a child class, which is something that inherits from this class right here. So we don't want to have to write in name and HP again. We just want to add the thing that this new class has special. Okay, so let's say a wizard, right? So if we say class of wizard, we're going to put the parent class inside of here, like so. And then we're going to say define init, like we did before. Put in everything we need, name, HP, and the new thing we're going to add in this subclass is going to be mana. So instead of having to write all of this again, well, we can just write super. So we can initialize this method by using super dot init. Inside of this, we put name HP, which is what is available in the parent class, right? So we're just, instead of having to write everything all over again, we can just borrow from it using this super method right here. Now this might seem, oh, well, teacher, why are you doing it this way? Because this seems like just equally as time consuming as doing it this way. Well, if you have an object that is much longer, let's say it has, something like this, then yeah, it'll be much more time efficient to use this super method, right? But for example's sake, we're doing it this way. Good. And the only thing you have to define is the new attribute, which is going to be mana, like so. Wonderful. Now we define our wizard as G, so we'll put G is equal to wizard. We'll put Kasim is the name of the wizard, and we're going to give him a HP of 80 and a mana pool of 200. Mana is just basically how much magic you can use. It's just a name for how much magic you can use. It's used in games. Good. We can also print here just to check that we are doing things correctly. G.name, G. I think it's HP, and G.mana. Let's see if we've done this correctly. Good, so yeah, Kasim 8200. And you can see that we created the mana correctly using super and using a subclass that inherits from the parent class, like so. Good, so super just basically allows us to reuse the character setup or the base class setup, which in our case is a character setup, so we don't have to repeat code. So what else can we do? Well, we can extend with super too. Okay, so maybe inside of a class character, we're going to have define a tag, which is equal to self. And inside of this, we'll put print self name and tax monster. Aha, okay, very scary. Why is there a mistake? Ah, yes, there we go. Okay, good. Now, we also need to have something like that for the wizard character, but a wizard character is a bit special, right? It doesn't just use a regular attack, it uses a magic attack. So inside of the wizard child class, or the subclass, we're going to define another action, like so. Define, we'll define attack, self. And inside of this, we're going to put super attack. So we're keeping the parent behavior, which is right here. We're keeping the parent behavior. And we are going, oh, and actually we're missing parentheses right there, brackets right there, good. And we're now going to say print self.name casts spell. So let's see what happens when we print this off. Okay, we'll do g dot attack. Let's see what happens. Okay. So Kasim attacks a monster, Kasim casts a spell. So you can see that it's added this extra bit here because, well, G is a wizard. But if I did, for example, C is equal to soldier, and we're going to give it a name of, let's do my brother, Hashim. Oh, actually, this should be character, like so. And inside this, we'll give him a house full of 200. Good, and we only need two things, right? Because character only has two things. And we'll also say C dot attack. See what happens. How do these things differ? Let's have a look. Run. Okay, so Kasim attacks the monster, casts a spell, Hashim attacks the monster. So Hashim only uses this part of the code, right? So yeah, this is basically a little bit about how we extend using super. So if we don't want to have to write everything again, we can just use the super method like so to reuse code so that we don't have to keep setting things up. So it basically lets, in our case, the wizard keep the basic attack and a magic attack too. Let's just do both, which is great. Okay, wonderful. So the next thing we are going to do is the mixed battle system. Let's just see how long this video is going for. 11 minutes. Okay, perfect. This is great. Okay, so the mixed battle system is a little bit more complicated, but it shouldn't be too difficult. Okay, so all we're going to do is we're going to create a class. Let's do class of creature, like so. We'll do define it. Inside this, we put all the usual stuff we need. HP like so. Self.name is equal to name. Self.hp is the HP. Good. And now we're going to make a warrior class that is a type of creature. So we'll do class warrior. Inside this, we put the parent creature. And we're going to say define init self name HP strength. Okay. And because we're borrowing from our parent class, we're going to use super dot underscore init underscore name HP because that's what's defined in our parent class. And this also needs a colon right there. Good. And then we're going to use self dot. Why is this coming up as? Why is there an error here? Super dot init. This is correct. Okay, maybe it's because I haven't finished it. Let's have a look. Equal to strength. Okay, so that's why it's not indented. Okay, there we go. Wonderful. Now we're going to make another one called class wizard, which is going to borrow from the creature class, the parent class. So we do the same thing. So we'll just take this actually. Actually, we'll write it again. Define init. And in the parent class, what is defined, we have self, name, HP, and we probably also want to do mana too, right? Because that's what wizards use, mana like so. Okay. Now we'll do super dot. Oh, there we go. Super dot init, like so. Inside this, we'll put self, or not rather, we'll put what we need from the parent class, which is name and HP. And then we're going to add the special thing, which is mana. Self.mana is equal to mana, like so. Good. Now we can basically use a new function, which is going to be like a battle turn function that basically checks to see if there's an attribute. And if there is an attribute, it's going to give us some different behavior. So it's basically useful in conditional statements. Okay, so we'll say define battle sequence, like so. Inside of this, we need to put creature, like so. Okay, good. And it has attribute creature strength. Then we are going to say, what will we say? Print creature dot name has used physical attack. Okay, perfect. Good. And we'll correct that like so. Let's see what happens. Nothing's happened. Okay. Well, if I give the function an argument, Let's give it a warrior class. So we'll say, we actually need to define this right first. So we put it right here. So we'll put a name of a warrior. Let's put the name of a warrior, Sun Tzu, which is a famous general. And inside of this, we're going to use the warrior class, and we're going to say Sun Tzu, like so. We're going to give it some HP and some physical strength, just 200. Like so. Now, battle sequence. Inside of this, we'll put Sun Tzu. Okay, and this should use a physical skill. Very good. So you can see that this takes in the class object, and then we're basically checking to see if the class object creature, which is the required argument, which we've given as Sun Tzu, has an attribute called strength, which it does because we're using the warrior class, and then it prints off uses a physical attack. But for example, if we have another warrior, let's say a famous wizard, I don't know any name of famous wizards, we'll use Houdini, which is a magician. Houdini is equal to a wizard. We'll call it Houdini, like so. We'll give it a HP of 50, and we'll give it a mana pool of 500, right? He has so much mana because he can use lots of spells. And inside of this, we can now put Houdini. But we've not defined anything, so nothing's going to happen. So we'll put in here elif has attribute creature, because that is the required parameter we've given. And we're going to check for mana. And if it has mana, so print creature name and attack using magic. Good. And why is this coming up? Yes, I've used a. There we go. Okay. Perfect. So now, if I run, you can see Houdini has attacked using magic. Now we can automate this, right? Well, not automate, but we can iterate this or iterate through this by creating a array, like so. So we'll just say for C, which stands for character, which is short for the base class of creature. Oh, sorry, stands for creature, which is and C is short for the base class of creature. We'll say and we'll just define the array right here. We'll say Sun Tzu and Houdini. Then battle sequence is equal to C. And this is basically going to do this twice. So now it should print off both options. Good, it has. Wonderful. So hopefully that explains that super handles shared setup for all the creatures in the base class, and then we want to extend into more subclasses, we can still use super, and it just makes it so that we don't need to write everything over and over again. Wonderful. And then has attribute basically makes it so efficient, so we don't have to write two separate conditional statements, one for the warrior subclass and one for the wizard subclass, for example. We can just use one for both subclasses, and that will be much more efficient using our time. So hopefully that clears up everything. I know this is a long video, but I'm sure this clears up your questions. Before you do this, I would encourage you not to just copy what I've done, especially for the last part where we looked at all of this code. I would like you to do it by yourself. So watch this if you have to, or if you want to, and then try and think about what I said. Go back in parts of the videos where you didn't understand and practice yourself, because I really think that practice is the best way to learn. That's in fact how I make these videos, right? I practice a lot before I make these videos because I want to make sure that they're polished for you. That's why I can code so quickly with very few mistakes most of the time. So hopefully this helps you with homework, and I'll see you guys again in the next video. Goodbye.